we are looking at lesson 1-6, scatter plots. And scatter plots involve graphing real people, real data, real results. So once you start graphing real life things, it's not always in a nice, neat line. People aren't perfectly at this height because they're this age, or whatever the relationship that it's studying. Everything isn't perfect. So what happens is you get what's called scatter plots, and the points that are plotted are maybe all over the place. But in general, when you're graphing real life things, you look for trends. And when you graph this, there's 3 possibilities. So if you look at my graph with the dots, the first one, they are generally going uphill. Now, if you're trying to put this on your paper, just remember it's anything that it's going from left to right, because you read graphs from left to right, it's generally going uphill. It's an upward trend. The points are not going to be perfect. So when you go to put this in your notes, you're just putting things wherever you can, kind of going uphill, just kind of imitating what I've got there. A positive relationship means this. As X increases, that means going from left to right. As X increases, the Y increases. So always read a graph from left to right. If the points generally go uphill, that is a positive relationship. So then the opposite of that would be if you are reading the graph from left to right and the dots are kind of going in a downhill trend, then that's a negative relationship. And how you look at a negative relationship, again, you always read a graph from left to right. So as the X's get bigger from left to right, the Y's go downhill. So do you see they start up high and then they kind of come down? They will not be in a perfect line, but it'll be a general trend. There are scatter plots, though, that show this. You see these dots? They're just all over the place. There's no way you can tell if they're going up or they're going down. So that means those things have no relationship together at all. All right, we are actually going to look at the homework together. So let me get that passed out to you. So we are looking at, not that, there we go. We are looking at practice 1-6 and some situations that could be placed on a scatter plot, and we have to determine whether it would be a positive relationship, a negative relationship, or no relationship. So here's what you need to think of. I'm going to do a picture like this. You don't have to draw this. I just kind of want you to watch. This is saying for number 1, a person's jogging speed. So whatever is first is along the x-axis. So this would be the jogging speed down here. And then this would be the time that they spent jogging. Okay? So you always picture this corner as 0. And as you go across this, their speed is going faster. So over here, they're going pretty slow, right? And if you look over here on the right, they're going pretty fast. Now let's say they're jogging the same distance every day. If they're on this side, okay, I'm trying to make a different color so you know where I'm pointing. If they're on that side and they're jogging very slowly, how long do you think it's going to take if they decide every day I'm going to jog 3 miles? It's going to take them a long time or not very long?
A long time.
A long time. So they're going to be up here somewhere. Okay, let's say that they're just starting out with this and they maybe get a little bit faster, how long you think it's going to take them? More or less time? Less time. It's going to be just a little less maybe. And as they keep doing this, if they really do it every day and they get faster and faster and faster, what's going to happen to the time they have to be out there, Tori?
It's going to decrease.
Yeah, so it's going to generally go down. Now, they may not be perfect every day, that it's exactly that time that they expected based on how fast they go. But if they get faster, their time outside should go down, correct? When you start high and you go down, look back at your notes. Is that a positive relationship, negative relationship, or none? Haley, what do you think?
Negative.
Yes, so for number 1, you should put negative. Does that make sense? Okay, so I got to erase all of this to get into number 2. So I want you to picture this. The size of a family. Okay, so this is the size of the family and the grocery bill. So remember, this corner is 0. Okay, if there's only 1 in your family, how much is your grocery bill, do you think? Tori?
Rather low.
Pretty low. But let's say you get married. Whoops. Let's say you get married, then you have a kid, and maybe another one, and they're boys, and they eat a lot. What's going to happen to your grocery bill? Sienna? It's going to go up. So the relationship between the size of a family and a grocery bill, what do you think? Positive, negative, or none? Layla?
Positive.
Definitely positive. Definitely positive. My son drank a gallon of milk every day. He went to college on Monday. We still have 2.5 gallons left in the house. I don't know that we'll get that drank or not before it goes bad because we don't do it. But he drank a gallon of milk every day, so my grocery bill is going to definitely go down. All right. Now, number 3, the size of a car and the cost. So if I draw this again, here's the size of the car, and here's the cost of that car. Now, we're talking, I'm going to put 0, but you know what I mean? It's a small car, and it's small over here, and it's large over here. So, think of some small cars, and think of some large cars. So, give me a type of a small car. Anybody? What do you think?
A clown car.
A what?
Clown car. They're like this big.
A clown car.
Or
Do people really drive that?
no. Clowns do sometimes in the circus.
Okay, well, I'm talking about a real car. Give me a small car. A bug. Okay, so a small car, a Volkswagen, so we're talking, it's probably about the middle of the road. Give me another small car.
Oh, a small car?
Yeah.
I have one for a large.
Okay, hold that thought. Small car. A Camaro, Mustang, they're kind of medium. So, they're very expensive, though. So I'm going to do that. Okay, Sienna? A smart car? Are smart cars expensive or cheap? Do you know? They've got a Mercedes engine in them, and I might be wrong. I think they're expensive. So it's a little car and it's expensive. But I thought for sure somebody would say something like a Lamborghini or a Ferrari, something really fancy, a sports car, or sports car small, Porsche, sports car small, and they are very expensive. And then if you think of a Ford Fiesta, do they even make that anymore? The little Ford Fiesta?
Like a Fusion.
A Ford Fusion, yes. Okay, they're small and they're cheap. Now, large car.
A Kia.
What's an Kia?
A Kia. There's not a Kia, it's just Kia.
Oh, a Kia. It's large? So there's different kinds of them, I think, possibly. So are they expensive or are they not? A large car that's expensive? I'm thinking, yes.
An SUV.
Oh, an SUV, are they expensive? Yeah. Okay, and I'm thinking like a Cadillac. Yep, they're expensive. But then I'm thinking of a panel van that they buy for a construction company.
That's cheap.
That's cheap.
Way cheap.
Okay, look at my scatter plot. Look up there. Do you think there's a relationship between the size of a car and the cost?
No.
No relationship. On number 3, no relationship.
Can we just put no, or do you want us to put relationship?
I would put no relationship. Yes.
Smart cars are actually pretty cheap.
Are they really? Okay, well
Yeah.
then they would be these down here. Okay, good.
Very cheap.
I thought maybe because I think they have a Mercedes engine in them.
They're expensive.
Yeah, yeah. Okay, so yeah, number 4. Number 4, a person's weight and their percent of body fat. Now, this one you got to kind of take it for what it's worth, because I've had kids argue this with me, and I would have to say at times I think they're right. But in general, the general population, okay, normal people, not bodybuilders or things like that, normal people. So I'm talking 0. The more people weigh, so 0, there's 100 pounds. Over here, we're going 200 pounds, and so on. What do you think somebody's percent of body fat might be between 100 and 200? What do you think?
As their weight gets larger, their percent of body fat would probably go up.
Absolutely.
For the normal
So it might be here or here, and then when it's 200, it might be way up here. In general, as a person's weight increases, their percent of body fat increases, so therefore this would be positive. Okay, one more I'm going to have to do really quick because my video time's going to run out here. Time spent playing video games and time spent outside. What do you think?
I think it's gonna decrease.
Yes, if you spend very little time here in the corner playing games, video games, okay, very little time, you might go outside more. But the more that you spend inside playing games, the less time you're going to go outside. So it's going to generally go downhill, which means what kind of relationship? Negative. That one's negative. Okay.